Alright guys, so we're going to try something new. We're going to do the notes online, so you can go at your own pace, rewatch things if you need to, and ask me questions when you need to, when you don't understand anything. So we're going to be doing exponential equations and being able to solve those today. So our I can statement is I can solve exponential equations with like and unlike bases. So if you remember, your base is what you raised to the power of something. So our exponential equations, all right, this means an equation in which variable expressions occur as exponents. All right, so for example, all right, we'll have our y equals, all right, we'll say it's 2 to the power of x minus 3. So we have an equation because we have a y equals, and it's an exponential equation because in our exponent we have an algebraic expression which we have seen before. All right, so the property of equality for exponential equations, to put it into words, this is 2 powers, so our exponents, with the same positive base, which we're going to call b, where b does not equal 1, are equal if and only if their exponents are equal. So to put this into something more concrete, an example would be if 2 to the power of x equals 2 to the power of 5, then x equals 5. And if x equals 5, then 2 to the power of x equals 2 to the power of 5. So far so good, hopefully. And then the last one, to say it algebraically, if b, our base, is greater than 0 and b does not equal 1, then b to the x equals b to the y, if and only if x equals y. So our two exponents have to be equal to each other. So let's go ahead and let's do some examples. So if we slide on up, okay, we have our first example of 3 to the power of x plus 1 equals 3 to the power of 5. Okay, so we have the same base. All right, so we set the exponents equal to each other. So we have x plus 1 over here and 5 over here, so x plus 1 equals 5. And then we just solve for x. So we subtract 1 from both sides to get x equals 4. Now for b, you have to remember there's really a 1 there, because if it's not to the power of anything, if you don't see an exponent, it's really to the power of 1. So we're going to do the same thing. We have the same base, and then we set our exponents equal to each other. So 1 equals 2x minus 3. I'm going to add 3 to both sides. All right, so 4 equals 2x, and then divide by 2 to get x equals 2. And then for our last example, 10 to the power of 3x equals 10 to the power of 2x plus 3. So again, same base, and we're going to just set our powers equal to each other. So 3x equals 2x plus 3. Because I have more x's over here on the left, I'm going to subtract the 2x from both sides because we have 2x on the right. So that gives me x equals 3. And that's our answer. So now what I would like you to do, all right, is give these next 3 a try. And then once you're done, have me check them before you continue the notes on the back side. All right? So make sure you check with me, please. Okay, so now we're on the back, and now we're going to be looking at exponential equations with unlike bases. So it's not going to be as straightforward as it was on the front, but all right, we can still figure out some tricks that will hopefully make this a little bit easier to digest and to do in the future. So because we have unlike bases, we're going to want to find like bases. All right, so you're going to look for common factors of both bases. Okay, so what number, all right, could possibly be a factor of both bases? Okay, so if it helps, what you can do is you can divide the bigger base by the smaller base. Okay, and we're going to try, I'm going to do an example to kind of show you how. So our first example, all right, we have 5 to the power of x equals 125. Okay, so to show this, how we solve this algebraically, instead of just guessing and checking, what I'm going to do is I'm going to do my second tip right here. I'm going to divide my 125 by my base of 5. So this divided by 5 equals 25. Okay, and then I know that if I divide this by 5 again, I get 5. So I'm going to count up how many 5s I have, which is 3. So 5 to the power of x equals 5 to the power of 3. And now because we have like bases, we can set our exponents equal to each other and get x equals 3 as our answer. Okay, so that one was a little bit easier. All right, still might be on the tougher side, but we're going to take this one step at a time. So now for this next one, we have 4 to the power of x equals 2 to the power of x minus 3. Okay, so what we're going to do is we're going to take our bigger base and divide it by the smaller base. Okay, so this divided by 2, all right, actually equals, all right, 2. Or it's really 2 squared, and then we also have to leave the x up there. All right. So then what we can do is we still set that equal to 2 to the power of x minus 3. And then again we have like bases, so we set our exponents equal to each other. So 2x equals x minus 3. And so again, all right, I'm going to subtract x from both sides to get x equals negative 3. So far, all right, examples have been on the easier side. Don't worry. Ask me questions. So this last one, okay, what I'm going to do now is I'm going to take a look at 9 and 27. Okay, so 27 is my bigger base. So I'm going to divide this by 9. Okay, so that's going to give me 3. Okay. But because, all right, if I divide that by 3, that's really 3 to the power of x, all right, times 9 to the power of x, I believe. Okay. So then we're going to break this down even more. So this is really 3 squared, right? 9 equals 3 squared. So now I have 3 to the power of x times 3 to the power of 2x. And remember our one rule that says when we have the same base and we're multiplying, we add the exponents. So this is 3 to the power of 3x. Okay, on the right side, we're going to do the same thing. So because this base is 3, I need to also make this base 3. So what two numbers multiply to give me 9? 9 is actually perfect square. So my answer would be 3. So I do 3 squared, and then in parentheses, I'm going to leave this x plus 2. And then if I want, I can distribute it to make my problem easier after this. So that is really 3 to the power of 2x plus 4. And then I'm going to set it equal to what I found for 27. So that equals 3 to the power of 3x. So because I have the same base now, I set my exponents equal to each other. So 2x plus 4 equals 3x. And then I just subtract 2x. So 4 equals x. All right, that was probably one of the tougher ones. If you understood what was going on in that one, then you're doing great so far. So what happens when we have to solve an exponential equation when b is between 0 and 1? What does that look like? So we're going to take a look at a now. So I have 1/2 to the power of x equals 4. Okay, so we need to get our bases to be the same. So 1/2 is really 1/2 to the power of 1. And remember, when I have a positive exponent in the denominator, that really means I have a negative exponent when it's in the numerator. So I rewrite 1/2 as 2 to the power of negative 1. So then in my parentheses, I can do 2 to the power of negative 1, and that's the power of x. Okay, so it looks like on the left-hand side, my base is going to be 2. So I have to do the same thing on my right-hand side. So to get a base of 2, I have to figure out 2 to the power of what equals 4. And 4 equals 2 squared. So this equals 2 squared. Okay, I'm going to use my power of a power rule on my right side to do 2 to the negative 1x equals 2 to the power of 2. And then I have the same base again, so we can set our two exponents equal to each other. So negative x equals 2. Alright, I just ignored my 1, and now I divide by negative 1 to get x equals negative 2. And voila. So this last example, alright, before you do the 4 problems down here on your own, okay, we're going to take a look at the right hand side first. So 64. Okay, we're going to do the same thing as we did on the previous problem. We're going to rewrite this, all right, so that it's not a fraction anymore. So 1 over 64 is really 64 to the power of negative 1. Okay? And then, like I mentioned up here, we're going to see if we can divide the bigger base by the smaller base, all right, so that it ends up being the same base. So we're going to try and see if we can get a base of 4 here on the right hand side. So 64 divided by 4 equals 16, and then divided by 4 again equals 4. So because I have 3 of those, all right, my base is going to be 4, and it would be raised to the power of 3. So this is 4 to the power of 3, and then it's raised all of that to the power of negative 1. And then I bring this down, and now we have matching bases. So I'm going to multiply these exponents right here with my power of a power rule. So 4 to the power of x plus 1 equals 4 to the power of negative 3. And then I set my exponents equal to each other. So x plus 1 equals negative 3. Subtract 1, x equals negative 4. Okay, now this is daunting, but you still need to give it an honest effort. Okay, so go ahead, give these next 4 problems a try, and again, check with Mr. J before you go on to the last section. So, last part of the notes now is actually going to be the easiest, because we get to use a graphing calculator to help us out. So for this last one, all right, it says use a graphing calculator to solve the following. And what we're going to do is we're going to make 2 equations based on the one equation that we are given. So what we're going to do is we're going to do y equals 1 over 2, in parentheses still, to the power of x minus 1, and then y equals 7. So all that we did was we set each side of the equation equal to y. Each part got its own thing. So now what we're going to do is you're going to get on to Desmos. All right, and I'm waiting for it to load right now. And we're going to plug these in. And we're going to look at where they intersect. So I have Desmos right here, and I'm going to type it in before I bring it up on the screen. So we're going to do y equals, all right, our 1 divided by 2 to the power of, of x minus, if I can figure this out, okay, give me a second. I'm going to figure this out. Just fast forward it to where I do figure it out. Okay, so I figured it out. All right, when you're typing in this one, all right, you'll want to put your exponent in parentheses as well. So when I type both of my equations in, all right, I'm going to go to where my two lines intersect. So they intersect at negative 1.807, comma 7. So if I take a look back at the problem now, we were solving for x, so we're going to do the same thing here. X equals negative 1.807. And we're not going to round it just because it's only 3 decimal places. So then for the next one, we're going to do the same thing. All right, so we're going to do a y equals 3 to the power of x plus 2, and then a y equals x plus 1. And we're going to plug those into our function lines on Desmos. So I will come back with that real shortly. So I went and I plugged them in. All right, still the same deal. You're going to have to put your exponents in parentheses. Otherwise, Desmos isn't going to like how you're typing it in. But if you notice, all right, my two lines do not intersect at all. All right, so you have this huge gap between the lines. So because they don't intersect, we are going to write down no solution, which is your favorite solution. Okay, so again, all right, go ahead, do these three on your own, type those into Desmos, and once you get done with that, all right, I'll give you the worksheet for you guys to do for homework. So let me know how you feel about this. All right, and if enough people like it, we can continue doing it this way. If not, we can go back to the way things were. But make sure you like, comment, and subscribe. Yeah, that's it.